This next question, C, says one experimental difficulty is that the incident atoms, that's the atoms that are coming in and being diffracted and striking the screen, that these incident atoms have a range of kinetic energies. We're going to find out exactly why that's a problem shortly. The next sentence says assume that they have a range of energies distributed between E plus a change in E and E minus a change in E, so that the mean energy is E. So putting that another way, we've got E as the energy plus or minus a certain shift, a range if you like, of E. So that extends from E plus down to E minus. The actual question C says explain why a range of energies, this is the range of energies, plus or minus delta E, explain why a range of energies will lead to poorly defined intensity maxima. So let's just really quickly refresh our memory. We've got a screen, we've got a double slit, and we've got an atom beam that's been collimated somehow or shut down so it's a single stream of atoms. And when it hits this beam here, they diffract at various angles, and with the spacing d, and they produce intensity maxima. We've got one at the centre at n equals 0, n equals 1, one down here at n equals 1 as well, and then 2 and so forth. So and we have to explain why a range of energies will lead to these maxima being poorly defined. So a really good place to start with this is our equation that we were originally given with, d sine theta equals n lambda, because remember this is the expression for the intensity maxima and helps us to locate them based on the angle of deflection or angle of diffraction. And since we're talking about range of energies, it's a really good idea to consider the expressions for the intensity maxima that we worked out before. Instead of being in terms of wavelength, we want them in terms of E. So instead we would have d sine theta equals n Planck's constant divided by square root of 2m E. Okay, so this time the intensity maxima is written in terms of E, and we can see that as E changes, it's just, I'll try and keep this really simple. You can play it through in a bit more detail if you like, but basically E is going to change, and that's going to lead to a change in theta. Why is that? H is constant, N is constant for that particular, if we say N equals 1 for each particular intensity maxima, the mass is constant as well, and let's take that, and 2 is obviously constant, and D is constant. It's the constant spacing of the slits between there. Okay, so of the two things that can change, the energy will change according to, well, the kinetic energy, the speed the atoms are sent through, and the angle will change. So if you have this range of E that's plus or minus delta E, it's going to lead to a change in your angle of deflection, meaning that you've got a range of your intensity maxima. The greater plus or minus E, you'll get a greater range of your intensity maxima ranging. And the next question talks about what happens when you get to the point where they start to overlap. So the zeroth, n equals 0 to n equals 1 might start to overlap, and what happens there. But we'll look at that in the next question.